On 8, there's a really nice trick to do. Obviously, you can subtract cotangent, set aside equal to 0, but it's easier to try to generate a squared term. Here's what I mean by that. What's the reciprocal of cotangent? Just tangent. The reciprocal of cotangent is tangent. So if I multiply both sides by tangent, I get 3 tangent squared equals 1.
That's what I did.
That's the easy way to do it. Because now I divide by 3. And I get what angle has a tangent value of plus or minus 1 over root 3. Well, Juan got it. She's dancing. She's happy. What angle gives me tangents of 1 over root 3? The 30s. So this is going to be plus minus. It's going to be plus or minus. I'm sorry. It'll be pi over 6. 5 pi over 6. 7 pi over 6. And 11 pi.
I accidentally verified them.
You verified that? Yes. The answer is yes. Did you verify the cotangent equals tangent one?
No, the sine
Cosine. That's the same thing. What you would do is multiply both sides by sine, get sine squared equals 1, and go from there. And it works out just the same, okay? Miss Hopkins, what do you got?
I just said for 6.
Yeah. I'll give you 10%. I totally forgot that. Sorry.
Can you bring it up? Because I did it all. I just want to make sure I did one part.
On 6?
Yeah.
Okay. On 6, what I would do here is kind of the same idea.
Because I did equals 1 over sine, and then when you multiply it by sine, you distribute it to the 2 sine and 1.
Yep.
Okay.
Keep everything balanced.
That's what I did.
If you multiply that by sine, multiply this by sine, you get 2 sine squared and a partridge in a pear tree.
It's not even this. That's what I did, but I wasn't sure.
Yeah. And then go from there. You guys said you're okay on 10?
I was just going to ask about 4.
4? Comes after 3 before 5.
Oh, I have a question about 42.
42 is after 41 before 43.
I have. Can you do problem number 4 for 4?
Es posible. What? Número 4 es muy importante para su clase de matemáticas y trigonometry. So, as this is very similar to one that we have done in the past, where whenever you have a squared term and a non-squared term, what you want to always try to do, it's number 4, what you always want to try and do is rewrite the squared term as the non-squared one. So cosine squared to turn into a sine would be 1 minus sine squared. So I have 4 times the quantity 1 minus sine squared plus 4 sine minus 5, 0. Distribute combine my like terms and I get this to be minus 1.
But then, like, if you do the split the middle term, it doesn't work.
Move to the other side. Positive, negative, positive.
I spent a good 10 minutes trying to, like,
Oh, you
actually
forgot
solve the
that.
problem. I forgot you did that.
Oh, that's right. You want to always move it. You always want that first term positive. Always want that first term positive so that way you can factor. What times what's 4? You add together get negative 4. Negative 2, negative 2. So this one winds up, guys, this is just a 4 sine squared and then it's the same thing twice. When you factor it all out, you wind up with 2 sine theta plus 1. I'm sorry, 2 sine theta minus 1 twice. So what angle has a theta of, I believe it's 1/2. Okay. Any others left over on that side if we flip it over? Yeah.
Number 7 or 6.
Guys, please.
Do 7 or 6. 7. Alright, 7.
We just did 6, and 7 is the same thing as 4.
Yeah, 4. We're gonna do 6 in the answer.
6 is the same thing as 4 by rewriting it in terms of cosine, and you might wind up you probably do the same thing with I bet you anything. It's a good that's what you done LeBlanc, what do you got?
I got no.
No? Well, that person wasn't very nice to help you. What's tangent times cotangent? 1.
I what?
No, that's a 0. Took her a second. All your 45s. Okay.
Oh, and then for number 5, I got to the end and then I didn't know how
You
to
guys stop talking so I can hear people. Rude.
For number 5, I got to the end, but then I didn't know like how to draw.
Circle the answer.
No,
Which
like
one?
How, where the angle.
To get to this?
Number 5.
All right. Well, let me come back here because so you did cotangent squared. So you did 1 plus cotangent squared minus cotangent minus 1.
Yeah.
Okay.
And then I got like cotangent angle for the 0 and then cotangent.
Okay. What is cotangent? Cotangent, if cotangent, what angle has a cotangent value of 0, you said?
Yeah.
And what angle has a cotangent value
Of 1.
of 1? Okay. So cotangent is the reciprocal function of what? Tangent. So that means that this is, tangent would be sine over cosine, y over x. This would be x over y. You okay with that? So that means where is x 0 and y equal to 1? See where I'm going with that?
Why is that? Oh, okay.
Okay. And then on the other one, cotangent being 1, that means you're on your 45s, and cotangent and tangent are positive in the same quadrants, so you're right there. Pi over 4, and then
So,
5 pi over
so
4.
that's the same as if it was like tangent.
Yes, yes. Yeah, Fleming, you had a question there too?
We have the same question. So you only have to answer once, but.
That's good.
So, you know how there's that like range of signs when it's only on quadrant?
This is that's
You don't
irrelevant.
have to do
Nope,
that?
nope, 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 nope.
Only when you're finding the angle.
Yes. And that's none of this. This is all solved within a revolution. Okay. All right, let's flip it over. Let's try some trickier ones. What I want you guys to do real quick is that you could go ahead and cross off 33, 35, 36, 43, and 47. I'm not going to get that. I'm not going to get into that style with you guys quite yet. All right, I'm not going to worry about it. I'm going to try and stick with a lot of the ones that have the Pythagorean identity to it, or ones that you can use some factoring to.
Wait, for 47, would you just square all of it?
There's a couple of things you can do there.
I'm gonna draw.
So I'm going to start with 45. It's funny.
I have a quick question. So if you had cotangent 0,
Yes, yes, yes.
you made that tangent, would that be 1 over 0?
Yes.
Which would be undefined?
Yep.
Okay.
And you'll get the same values. It's wherever x is 0.
Oh, but is it undefined just like now?
Well, no, if it's undefined, it's 1 over 0. Where is that undefined? Where is tangent undefined? At pi over 2, 3 pi over 2. Where is cotangent 0? Pi over 2, 3 pi over 2. Let's start with 45.
Is this the same thing from last night?
Yes, but I'm going to talk about all of this stuff today on this backside in terms of general solutions. Just to kind of get us, what, if your name was Dan, it'd be funny. What's going to help us with that is the budget legs. Quick review on how to do that. We're going to list this out in terms of general solutions, which means we might have to add in some pi values at the end. We solve everything the same way, but then we're going to look at the occurrence levels within the revolutions.
What number is this?
This is 45.
45.
Thank you. Sine to the fourth x minus 1 equals 0. No. Is the first term perfect square?
Yes.
Is the second term perfect square?
Yes.
Is it a subtraction symbol?
Yeah.
So you get sine squared minus 1, sine squared plus 1.
Would you break up the -1?
You can.
Would it be the same thing now?
Yes. Because here then you have what angle has a sine value of plus or minus 1. Sine is which coordinate on the in your ordered pairs? It's the y value. So this is asking us then, where is sine? Where is the y value? 1. Well, the y value has to be 1 at pi over 2 and negative pi over 2. So that means that my possible solutions would be up at pi over 2, 3 pi over 2. But then you'll notice that these two guys, they're equidistant from one another as you go around the circle. I will get from pi over 2 to 3 pi over 2 in how much time? In 1 pi. And it takes me 1 pi to come back up, doesn't it? So the general solution would be pi over 2 plus pi n. Okay. Whereas on the other one, I would have to subtract 1 and take a square root. I can't do that. So the other one is a no. Because I can't take the square root of a negative. Okay. It's inconceivable. Best a Sicilian in a game of wits. Okay, so that gives me my answer for that one. Okay.
What happened to the final question? I actually owned it on Friday.
Let's do a general solution. Let's do a general solution with a Pythagorean identity. Okay? So I have cotangent squared minus a cosecant is 1. Well, that means we have to remember how to rewrite one in terms of the other. Cotangent squared plus 1 is cosecant squared. Therefore, cotangent squared can be rewritten as, yes sir?
Cosecant squared minus 1.
Very good. So I rewrite that, and I get cosecant squared x minus 1 minus cosecant x minus a 1 is 0. What I'm doing here is just preemptively moving that 1 over because I'm going to have to factor with it anyway. Combine my like terms, I get cosecant squared minus a cosecant minus 2. What times what is negative 2 that I add together to get positive 1? Negative 2 and 1. So this is going to be a cosine, or cosecant x minus 2. Cosecant x plus 1 is 0. I don't need to worry about splitting the middle term here
Why is this 4?
because I forgot to not put it there. And I was just about to say, this is one that you don't have to write up in terms of factoring GCFs because I'm so used to having to do GCFs because that first term I don't have a first term that's a coefficient, it's not, it is 1, so it's easier. Now, this means what angle has a cosecant value of 2. But this is very good, but the sine value is 1 over 2. So a lot of times when you get to solving for theta value here, if you have an inverse trig function, a lot of times what I would suggest that you do is rewrite it in terms of its standard form. Knowing that cosecant and sine are inverses of one another. So if I turn cosecant into sine, that means I have to flip the 2. So it's also the same thing as what angle has a sine of a half. And I think we've seen that one quite often. It's your 30, so it is at pi over 6 and 5 pi over 6. Are those two equidistant from one another? So what do you have to tack onto both of them? Very good. Okay. Then I do the same thing on the other side. The other side is asking what angle has a cosecant of -1. Which is something that I can do. Cosecant has the same domain and range as sine. So the reciprocal of -1 is still -1. Bless you. So this is the same thing as saying what angle has a sine of -1. Sine is which of the ordered pairs?
Why?
Why?
I don't know.
Because it comes last in the alphabet.
I was
Cosine
asking
X.
why is it why?
So I was. Sine, y, letters later in the alphabet versus cosine and x. Anyway, so where is it? You said at the bottom. What is the bottom called? 3 pi over 2. So is that the only place that it occurs?
Yes.
So what do you tack on? So can you guys see why I didn't want to put all trig identities and equations together at the same time? What's that? But now once you start to see them, it's not as bad, is it? Because your answers are still going to wind up being within that unit circle. There's nothing that falls off the circle. It doesn't go into a triangle, or I should say triangle. It doesn't go into like a quadrilateral all of a sudden. That's just crazy. That's why I stopped. Not each triangle.
I'm glad you didn't say that's what pre-cop is for.
I gotta leave them something for you to do.
Very generous.
I don't want to swear that. That sounds weird. I don't think it's gonna get you.
What would get me somewhere?
Your feet get you places. That's always a good sign. It's true, you can have a bump flipper. Now, in this case, there's a couple of things that you could probably do. I think you might have an idea.
But could you divide each side by tangents? And then like tangent like a cosine.
Well, I see where you're going with that. Because if you multiply,
Oh, I see
what he's saying is that instead of saying tangent, if I say this is sine over cosine, is that okay?
Yeah.
Now, if I multiply both sides by the reciprocal,
And you just get cosine on the one side. And wouldn't it still be 2x on the other side?
over here, this is all sine x, cosine x, all the x values all go away because in order for any of these things to work, they have to have the same theta values. They have to have the same angle. I just get lazy and, so what happens here is you get the square root of 2 equals 2 cosine x. Which means, what do you do? Divide the other side by 2. And now it is, what angle has a cosine of root 2 over 2.
Okay, but I thought if you, like on the left there, you're multiplying cosine over sine by sine over cosine. Wouldn't that make it some weird like common denominator with like addition?
When you're multiplying, do you need to worry about your denominators? No.
So that's almost.
Yeah, it just becomes 1. What I'm doing here, in essence, what I'm doing here is something very similar to taking 3/2 x equals 4. And I got to get rid of, I want to get the x by itself. I multiply by a reciprocal to create some power of 1. Well, it just so happens my reciprocal here is cosine over sine. And this all becomes 1, and then it's just 1 times the square root of 2 for that side. It's another way of representing a fractional value that gives me a value of 1.
Okay, and then after that, could you just divide both sides by 2?
Yep. And that's how I got root 2 over 2. It's rationalized.
Oh.
Okay, it's rationalized. It's your 45s.
yeah.
Yeah, so that would be 1 over root 2.
Yeah. It's your 45s. Now, it's positive. What 2 quadrants are cosine positive in? 1 and 4. So your answers then would be at pi over 4. And then if I'm in the 4th quadrant, what do I tack onto both of them? You guys are gonna like freak out when on Friday I can tell you, use your calculator.
We're going to probably not have
I bet you none of your calculators are even sharps.
Mine doesn't charge.
We haven't used them in how long? Nice. Because we will eventually, I'm not lying, you will be allowed to use your calculators in a couple of days. I know. But, and see, but here's the thing though. Remember how you guys threw a fit of rage that you weren't going to use a calculator for like 6 weeks?
Yeah.
Have you survived?
No, not really.
Yes.
True. But for the most part, have you come through partially unscathed?
Well, Kirsten got scared. She was only in my practice all around the same time. And so she got pulled off of the wheelchair.
So she's scathed. Try another one.
I hate unless taking it.
What's the problem with Scotland? It's full of Scots.
Should be.
You've never seen Robin Hood?
That's
Is it Robin
not
Hood? No, it's not Robin Hood, it's Braveheart. We get to kill the English. It's great. That line's great. Let's try another one. Let's try one more of these. Now, a nice giveaway for some of these problems is that if the trig identities, the trig stuff that you're working with, are the same on both sides, no, because if you do that, you eliminate a possibility.
Oh, you can't square it.
Remember, you couldn't do this. X squared equals x. You couldn't just divide by x and get x equals 1. You couldn't do that because you eliminate the possibility of it being a plus or minus and stuff like that. So, same deal here. Set aside equal to 0. Yeah. Because now you've got your GCF. You don't have to worry about common denominator. You don't have to break it down. Yeah. So I saw some people try to do that when they saw tangents. Oh, I got to rewrite in terms of sines and cosines. Oh, please don't when you get to things like this. You're just going to make your life a lot more miserable. Here, again, just factor out a tangent. That's their GCF. Take a tangent out. And now you have two terms that you can set equal to 0. Where is tangent equal to 0? What angle has a tangent equal to 0? Oh, did you want me to write out what the term is before I do that? Are you okay by me skipping to this point by now? Is it okay? I've kind of been skipping that stuff, and nobody's been yelling at me more so than normal. So I. Okay, so you got it already. Okay. We just did a problem like this not too long ago about cotangent being 0. This case, it's tangent equal to 0. That means it's y over x. So I'm looking at where's the y value 0. Where's the y value 0 and the x value 1? At 0 and at pi. Because y is 0 at 0. And y is 0 at pi, because your x values are 1 and negative 1. Okay? Yep, that's all you do. So my answer then for here, oh, actually you would write it as 0 plus 2 pi, or plus pi n.
Oh, okay. I know. Oh, yeah.
Because you wrote pi plus 2n, you just become the negative value. You got to oscillate between the two. So just write 0 plus pi n. Or some people just write pi n, because it's the same thing.
Yeah.
Okay.
Because then 0.
The next one is the root 3 over 3, which means that your it's been rationalized. So it's 1 over root 3, which is your 30. Good. 1 and 3, which the other one is. And what do we tack on? Oh, yes, because here, sorry, I got ahead of myself. I was thinking it was in the second quadrant. Silly of me. So, since pi to 7 pi over 6 is just 1 pi away, pi away with me. Come pi with me to the stars. So here you'll have to use another pi n. That I wonder if that guy with the hippie hair did the song "Come Pi with Me." You know what I'm talking about? Matt, Paul McMath. I'll just be him for Halloween next year.
You should teach
I don't know what we're teaching next year because our class sizes are going through the roof, so we have no idea. So it's going to be interesting.
You're just going to teach in the forum room?
Probably.
Teaching auditorium?
If you think about it, right now I have 3 sections of honors algebra 2 for next year because there are, I think, 79 students signed up for it. So next year, that means that if they cut back a section, I'll have a section of 39 and 38 kids.
Don't worry, they'll all probably drop out.
And then they won't have room to. They won't have room to because all the other algebra 2 classes will be at 38 and 40 anyway. So it's going to be interesting.
Drive all the minutes and kids have to drop out.
It's going to be interesting. I don't know what to tell you. Do those 6
Thank you for not giving me
general solutions with those 6, please. We'll try those out. We'll check them tomorrow. There's a nice little trick with number 41. All right, there's a nice little trick with 41. I want to see if you can figure it out and go from there. Yes, ma'am.
Thank you.
I will probably start being more religious about homework, starting with sequence and series, because there's so much material and I want you guys to be able to go back and look at same style problems and have it with you after I've worked them again. Does that make sense? I mean, there's no reason. You're doing your homework. Why do I mean,
Oh, yeah.
you know, if I saw all of you not writing anything out or having anything with you at all, I'd be getting a little peeved, but.
Mr. Blumhigh.
Yes, ma'am.
I was absent one day and then you told me